Number 3, negative 210. In the second quadrant, correct. Didn't sound so confident then, but negative 90, negative 180, negative 270. Remember, when it's negative, I go clockwise. Since it's got to be in standard position, where does one side of the angle always have to be? You guys that were here yesterday, one side of the angle always has to be 2. We graphed a ton of these yesterday.
Yeah, wait.
One side of the angle always has to be where for standard position?
The x-axis. Are we on the homework right now?
No, I just made this up
Oh, okay.
because I have to know that you guys are good here before I move on. What is that side called that I just put on the x-axis? Let's go vocabulary. What is that side called? 8. Initial side, yes, or array, that's good too. Ready? Yep. Initial side. Then we have the other side, which goes in what quadrant, Ben? Quadrant 2, because it's negative 210. Is negative 210 closer to negative 180 or negative 270? Negative 180. So I'm going to draw it closer to 180. What's that side called? We just had initial side. This side, wherever it is in whatever quadrant, is called the 10? Terminal side. Thank you. Terminal side. My diagram is missing one thing before I let it go. What am I missing on the diagram? 5. Rotation arrow. Making sure it's going in the correct direction. Why is it going clockwise for this one? It's a negative degree measure, correct. So that's how I graph negative 210. Questions there, because I'm going to build off negative 210 now. Can you come up with the smallest positive angle coterminal with negative 210? So basically, same diagram, but give me the positive version now. How many degrees in the positive version, and how did you get it? 5 again. What do I do to negative 210? Go ahead, add 360 to it. 150 degrees, yep. 150 degrees. Questions? Go ahead, Mary. What do you mean 90?
Or, not 90. Well, like yesterday wasn't the smallest one, whatever. Like, one that was in between.
No, you're thinking of reference angle, which we're going to now.
Oh.
All right, this is the same angle. Remember, coterminal means give me another angle with this terminal side, which is 150. Are we all good? Okay, here's where we got to live here for the next couple days. Reference angle. What's the reference angle for negative 210? So you guys describe to me, how is a reference angle formed? With what sides? Brett?
Isn't it like the terminal?
Okay, the terminal side and the
x-axis.
X-axis. Now, hey, with the X-axis, I could go this way or I could go this way, but somebody remind me, a reference angle is always what? Acute means it's less than 90 and it's always positive. So here is what I'm highlighting in yellow is the reference angle. How many degrees in that reference angle? And you should have enough info to find it. Well, you just know this angle was 210. That's 180. What can I do with the two? Jenna? Find the difference between 180 and 210, and what is it? 30 degrees. So the reference angle is 30 degrees. It's always between the x-axis and the terminal side. And that's basically what we did all period yesterday. One of the rare times I spent most of the time up here teaching. No questions you have? We sure about this? Because I'm going in a different direction, but that stuff is going to come up over and over again in this unit. Nothing else? Okay. You got it. Whew. Also, Monday, if you're not here on Monday, we're doing a group assignment. So if you're not here for it, it's on your own, remember. Okay. Anytime you're asked to find an angle measure, it's always in what units? It's always in what units? Degrees, right? Your whole math career, degrees. Until today. There is another way you can measure an angle other than in degrees. You remember maybe last year, maybe geometry, you guys used to clear your calculator memory, and then you'd have to go back to the mode and put it in degree mode. Anybody ever see what the other one was right next to it? Radian. All right, you don't have to do that. I'm just showing you. Okay, that's the other way you can measure an angle, what's called a radian, and that's what we're going to start working on today, Monday, Tuesday, Wednesday. All right, it's a 3-day topic here. All right, but the other way you can measure an angle is in radians. Okay, now I had this big, huge demonstration planned and hands-on activity, and I just decided, you know what? I don't even know if you guys care. Let's just get right to it. Okay, let's just get right to it. All right, for radians. Here's what you could think. First, need your formula sheet out. All right, let's get your formula sheet out. Anybody need a formula sheet? Right over there, if you need one. Here's what I'm going to do with you today. We're going to convert from degrees to radians and then back from radians to degrees. First thing, if you want to know, 1 radian is about 57.3 degrees. Okay? 57.3 degrees, 1 radian, if you want to know. Okay? We have a little bit more exact conversion on your formula sheet that we'll use. Okay, but 1 radian is about 57.3 degrees. Okay? All right, let's just hop into the first question. I'm going to draw an angle in standard position. It's 2 radians. What quadrant am I in? Okay, 2 radians. No idea. You can pick a quadrant. Heck, why don't I throw out quadrant 7 from yesterday? Okay, I can throw that out there. Yep, I'm sure that's always going to be a choice. All right. You guys only know the quadrants when it refers to what? Not radians, but degrees, right? If I said 2 degrees, what quadrant would I be in? 1. If I said 100 degrees, what quadrant would I be in? Okay, so you guys know what quadrant in if I give you degrees. So what I'm going to show you right now is how to convert 2 radians into degrees. And the way we're going to do that is on your formula sheet. Okay, so everyone take a look at your formula sheet. In this problem, I gave you radians, correct? So do you see the column here where it says radians? 1 radian equals 180 over pi degrees. That is the conversion we're going to use right here. If you guys do me a favor on your calculators real quick, do 180 over pi real quick, and that number should look familiar from a couple seconds ago. What's it about? 57? What do you have with 180 over pi? About what? About 57.3. Instead of using 57.3 every time, I want something a little bit more exact, and I want 180 over pi. Okay? So that's the conversion we're going to use right now is 180. I was given a radian, 180 over pi. So go back to your problem. How many radians do I have? 2. So I'm going to take 2 and multiply it by that conversion on the formula sheet, which was what again? 180 over pi. So 2 times 180 over pi. So we go back to your calculator. 2 times, get a fraction template up if you have one. 2 times 180 over pi. And that's about how many degrees? About 114, 115 degrees. So it's about 115 degrees, which would be in what quadrant? 115 degrees, quadrant 2. All right? And do you need to memorize that conversion? No, because it's on the formula sheet. 7 radians. 7 radians. I'm still going to multiply it by what? 180 over pi, because that's my conversion. About 57.3 degrees. So 7 times 180 over pi. Ooh, 401. Got to go around again, huh? Quadrant 1. Yep. All right, not too bad yet. Not too bad, just dipping your toe in. All right, here we go. Now let's get into it. All right, now let's go the other direction now. Now I'll give you it in radians. Well, this is what we've been doing. Give you it in radians and now turn it into degrees for me. Now notice, you'll see something different. Notice on the last 2 questions, it was just boom, 2 radians, 7 radians. That was it. Now I'm putting a pi with it. 7 pi over 6 radians. What is it in degrees? And just so you know why I'm doing that, why we're putting a pi with it. 7 pi divided by 6. So I don't have to write that many radians out. Okay? So I don't have to write 3.665191429 radians. Okay? It's a little bit more precise to put the pi with it. Everyone good? That's how many radians I'm asking for right now. But I just put the pi with it to make it a little bit more clean and precise. Okay? All right, so I have 7 pi over 6 radians. What am I still multiplying it by according to my formula sheet? 180 over pi. And watch this now. This didn't happen in the last 2, but it will now. What's going to cancel out? What's going to cancel out? Pi. See ya. And now I'm just doing 7/6 times 180. And that'll tell me how many degrees are in 7 pi over 6 radians. Oh. What?
I don't know why I thought that number.
I'm multiplying, right?
Yeah, I thought.
So I can cancel them out as long as I'm multiplying. I put an equal sign in between it, no go. But since I'm multiplying, go ahead. And what do you got for me here? Actually, nope. I'll ask somebody. 14? 210 degrees. Yep. 7 pi over 6 radians is the same as 210 degrees. Questions? All right, we okay? Multiply by 180 over pi. Because now I'm going to go other direction. Here's 120. What is it in radians? So now go to your formula sheet. Everyone look back at your formula sheet. Everyone see the one where you're given degrees now. Now what am I multiplying by? Not 180 over pi, but pi over 180. And be careful, don't hit your calc buttons yet. So 120 times pi over 180. Let me do it. Don't you. Let me do it. Let me do it for you. 120 times pi over. Look good? I don't want that written down. That's sloppy to me. I don't want that written down. I want it more precise. All right, more clean than this random, wacky decimal. How can I clean it up and make it more precise? What do you think, Jenna? Well, okay. Won't do it. I like the suggestion, but won't do it. And I'm not accepting that. I need it more precise and clean. What's up, Alex? Leave the pi in your answer. Nice. Leave the pi in your answer, and the only thing I want you to do is reduce 120, ready? 120 over 180. Leave the pi in your answer. Thank you, Alex. Nice call. So that reduces down to 2/3. So my final answer I want, instead of that 2 point da-da-da, whatever that was, 2 pi over 3 radians. Okay? 2 pi over 3 radians.
I'm sorry, but like I'm a little confused. So you got the pi on.
I got it right off the formula sheet, Brett. What was 120? What?
I know that. But like,
How do I multiply fractions? Numerator times numerator. 120 times pi. 120 pi.
that gets you 2.
120 pi.
It does make 2.
Denominator. 1 times 180. Leave the pi in your answer and reduce the fraction. Good? Okay. Other questions? All right. I'm just flipping it on you. See where you are now. Convert the following radians. So these are in radians. Turn it into degrees for me. Okay, turn it into degrees for me. So I have 5.8 radians. Now I'm going to ask you guys, what's the conversion? What do I multiply by? Look on your formula sheet. You're given radians. Given radians. Look on your formula sheet. What are you going to multiply by? 8. What am I going to multiply by here? 180 over pi. Am I allowed to cross off the pi's here? No, there's only one of them. So plug the whole darn thing in your calculator now. Because it says round your answer to the nearest degree. There's nothing to cross out. 5.8 times 180 over pi as a fraction template. Round to the nearest degree for me. When you're ready, 6. What is it? I'm trusting you. I don't have my key in front of me. 332? Okay. Did we have negative angle measures yesterday? Did I give you negative angle measures yesterday? So you can have negative radians then. All right. Nothing's going to change. I'm still going to take negative 2.5 and multiply it by. If it's in radians, what do I multiply it by according to your formula sheet? 180 over pi. Can I cross off any pi here? Nope. So multiply it through, round to the nearest degree. When you're ready, 19, when you're ready.
I got 143.
How's that look? I'm trusting her. Thanks, Rachel. Is it that bad? Just look on the formula sheet. Here's what we're going to get into, though. Not today, though. Everything we did yesterday, do it all in radians now. So graph it in radians. Find a reference angle in radians. But you know how to do what? Convert from radians to degrees. So it's just an extra step. What do we got up next? Oh, speaking of that, here we go. Find an angle with a positive measure and a negative measure that is coterminal. Ooh. What did we do with coterminal? Add or subtract what yesterday? 360. Add or subtract 360 from it yesterday. All right, but, ooh, wait a second. I can't. This is in what type of units? Radians. So I just can't add 360 because 360 is in degrees. Ah, geez, that's not going to help me. Son of a gun. Anybody got any suggestions? You're not adding 360 because you can't add radians in degrees. Ashley? Convert 5 pi over 2 right now. Convert 5 pi over 2 into degrees. All right, breathe. Look on your formula sheet. This is radians. So what am I going to multiply it by? 180 over pi. What's going to cross out? The pi's. And you're just going to be left with, what is it? 400 and, yep. Yeah, 450. Okay, 450. So what am I going to do to it to get a positive and a negative here? What do you suggest I do to 450? There's a couple things I could do here. 450, if I want another positive or a negative angle, what can I do with it? Take in, let's turn it over to you guys. 3, what can I do with it? Okay, ready? Everyone ready? 450 minus 360 gives me what? 90 degrees. Okay, that takes care of my positive angle. How are you going to get it negative? I asked for a positive and a negative angle. You got me a positive angle, positive 90. Where do I get my negative angle from now? Keep thinking about it. Where do I get my negative angle from? 16 suggestions? Where do I get my negative? Like 90 is my positive angle. Keep subtracting 360. So 90 minus 360 is equal to negative 270. Yep. I have bad news, though. I have bad news. Anybody know what my bad news is? What would you say, Art? That's what I thought. What's the deal? Okay, never mind. Mike, I don't have any pets, sorry. I don't have any pets, sorry. Bad news? Anybody want to guess what my bad news is? That we're not done? No, it is. It is. We're 100% right here, but we're just not done. No. What was the original angle in? Okay. Your final answer has to be in radians. Okay. Now what? I'm going to do this a different way for part B to see if you like it a little bit better. All right. But for now, yes. If your angle starts in radians, your final answer has to be in radians. All right. So we got to convert 90 to radians right now. What's the conversion on the formula sheet? 90 times what? 12. 90 times what? Pi over 180. Do we have a 12? Yeah, I know that. That's why I'm asking if we have a 12. No? Nobody was going to start yelling that we didn't have a 12. 17?
We don't have a 17.
8. Why don't you shut your mouth? How about that? Okay. 8. Do we have an 8? It's fine. We had a little confusion here. What do I multiply the degrees by to get back to radians? According to the formula sheet, I'm at degrees. How do I go back to radians? Multiply it by? Yep, pi over 180. And you guys know I want to leave the pi in the answer and reduce. Jenna. This is degrees. Degrees to what? No. Where? Where? Degrees. Pi over 180. Okay. I'll do the teaching. What's 90 over 180 reduced down to? 90 over 180 reduces down to 1/2. So this will just be pi over 2. And go ahead, I'll give you a second to convert negative 270. Multiply that by pi over 180. So it'll be negative something. And that's going to be what? Negative, what fraction did you get for this one? 8 again. On fire today, Maddie. Negative. So you're multiplying it by pi over 180, right? The pi stays in your answer. So the only thing you should be reducing is negative 270 over 180, which your calculator will do for you. Got it. Okay, so those are my final answers here.
Wait, 270s over pi? Wait, I think you said you're crossing out.
Negative 270 pi over 180.
Yeah, so I got 4.7.
Okay, we talked about that, Brett. I don't want that sloppy decimal. That's why you're leaving pi in your answer and reducing negative 270 over 180. We good?
Yeah.
Okay, look, I'll even agree. That was a heck of a lot of work for one problem. Convert, subtract, convert back again, yeah? Okay, there's got to be an easier way to do this, and there is. What did you add and subtract at the beginning? 360. So why don't you just add and subtract the equivalent to 360, but in radians? What's 360 in radians? Let's find that out right now, because that's something you're going to remember throughout this unit. What is 360 in radians? So 360, we just do it off to the side here. What are you going to multiply it by? 3. This is degrees. 360 degrees. What are you going to multiply it by? Here you go. 9. What do you want to multiply that by? We have a 9 or no? Okay, well, I'm not going to. I'm turning 360 into radians. You have a formula sheet in front of you. Is this in degrees or radians? Okay, you have a column that says degrees. And what's it say to multiply by if I need to get it to radians? Okay, here we go. Pi over 180. What have I asked to leave in the problem? When you convert, what I don't want you to touch? The pi. So what are you going to do in your calculator right now? Okay, so let's do that. 360 over 180. (360 degrees is the same as 2 pi. Ready? So instead of converting this right now, take 4 pi and add what? Or subtract, here you go, subtract what? 2 pi. It's the same as 360. What, Art? Well, you could add it. Well, what's the goal? What's the direction say, Art? I need a positive and a negative angle, correct?
Yeah.
I don't care how you do it. Add it, subtract it. Because, Art, ready? 4 pi minus 2 pi. What am I going to get? That takes care of my positive answer. Good? All right, what do you want me to do to get to the negative answer? So 2 pi minus, where am I now though? Okay, that's not positive or negative, so keep doing what? Subtracting 2 pi. So my negative answer can be negative 2 pi. So that's probably the best way around this is add and subtract 2 pi instead of converting, subtracting, converting. All right, because that was a lot of work. And the final thing I'm going to ask you to do, graph it. Negative 5 pi over 6. What am I going to have to do first? Change it into degrees. Yep. There isn't, that's the only converting you're going to do. So go ahead, I'll give you a second, convert it into degrees. And it's just looking at the formula sheet. Michelle, when you're ready. What is negative 5 pi over 6? Okay, negative 150 from yesterday's class. Now we graph it. What quadrant? Negative 150. What quadrant should you be in from yesterday? 19?
Since it's negative, it'd be third quadrant.
Correct, because that's negative 90. That's negative 180. Where's it closer to, Rachel? Negative 180, so make it sure the terminal side is closer to it. And what's the only thing I'm missing?
Oh, the rotation.
Yep. And then 13 pi over 8. And there is good news. By the time the end of next week hits, you won't have to convert anymore. You're going to know a trick real quick that you can go negative 5 pi over 6. You're going to do a couple quick calculations in your head or your calculator and tell me negative 150. You won't have to convert anymore. 13 pi over 8 is about, it's a decimal, right? Or no? Yeah, it's a long decimal or just 0.5? Okay, that's fine then. Yeah, that's what I thought. 18, what do you have? None. Oh, all right. 17?
No, 17.
I'm going to get it soon. 3.
292.5.
Okay. 292.5. What quadrant am I in? 4? What is it? First? If it was negative 292, I would agree, but it's positive 292. Fourth quadrant, yep. Closer to 270. And rotation arrow now going counterclockwise. All right. Please do not do the bookwork at all, because that is going to be your graded assignment. If you're not here on Monday, that's what your graded assignment is. All right. My suggestion would be, if you didn't try the assignment out last night, might be a good idea to do that. Okay, but that's what the group assignment's going to be. What's on the bottom of that page right there. Okay.